गुड मॉर्निंग फ्रेंड्स, कैसे हैं आप लोग? आई होप यू पीपल आर वेल. टुडे I would like to talk about vibration technology, the importance of the vibration technology. As you know very well that in maintenance, particularly when you are applying the condition monitoring and condition based maintenance, it is very necessary that you should apply the vibration technology. Vibration technology is maybe more than 30-40 years old or before then. uh, People used to say that when there was no measuring instrument, there was no how to measure the vibrations, people used to put the coin on the bearing housing and they would like to know what is the severity of the vibrations. So it is very important that it has been very useful in predicting the source of the vibration or why the vibration is happening, the root cause of the vibration. So regarding the equipments, you know very well, we have a different capacities, compressors, type of compressors, reciprocating, screw, centrifugal, and pumps, different type of pumps, reciprocating pumps, centrifugal pumps, and different type of, you can say, constructions, barrel type of construction, or you can have a only single stage one impeller or multi stage multi impellers. So different type of, pumps you will have, different type of compressors you will have, different type of, you can say, location of bearings you will have. So all this covers in the vibration measuring technology. Vibration you can measure not only on the proper bearing housing, but you can measure on another components like the casing, like you can say sometimes other parts, legs, base plate. So it will give you a lot of information. Now, what type of vibration you should use and what type of knowledge you have and what type of, you can say, experience or you can say qualification you need. So generally what happens in the vibration, there are standards, there are, you can say, certifications. So these things are, you can say, decorations, but main thing what you would get from the vibration technology, the skill you can do only when you are doing repetitively. So there are, you can say, two types of measurements we are taking in the industry, particularly oil and gas industry, hydrocarbon industry, because this industry is slightly different in the safety point of view. So whatever the constructions of the measuring instruments is slightly different than what you will use in the power or any cement industry or other not so hazardous industry. So what you will do, that you should have the equipments measuring and as well as the analysis equipments, they should be intrinsically safe. What they call it intrinsically safe, that in the manufacturing itself there should not be leakage of the battery or, you can say, charge or spark when you are measuring in the field. So first and foremost thing, that all these equipments should be compatible to our your hazardous area regulations. Now second thing comes, what type of, vibration measurement casing practices are there. I would like to clear here itself that when you are using the portable instrument, when you are not having any online transducers means the probe, vibration probes. When you are having the portable transducers, portable measuring instrument, then you can generally measure on the casing vibrations. When you are having the online, then the probes are installed and they are continuously taking online live 24 hours continuous vibration measurement. So first I will talk about the casing vibration and second I will talk about the shaft vibrations. Now in the casing vibrations, there are, practices that when you should take the vibration. Generally all the equipments are having the fundamental basic signature of each and every equipment. What do you mean by the basic signature? That you would take the vibrations, there are two things: overall vibration of any equipment, and in any equipment generally you have a four bearings, two bearings on the driver side and two bearings on the driver side. In case suppose if you are running the pump or in compressors, you will have motor and you will have the driven equipment, pump or compressor. Generally in the pump you will have a bearings, two as a pair of bearings you might be having, or you can say both side of the, you can say, pump you will have the bearings. In a similar way, compressor you can have the bearings on a different, you can say, shafts. Suppose if you have a multi-stage compressor and are integrally geared compressor, so you might be having the gearbox and you will be having the shaft based on, you can supported by the bearings. So you have to identify the bearings, and each bearing housing you will take the casing vibrations, and these casing vibrations are generally taken in the three direction. This direction known as the horizontal, vertical and axial. I would like to tell you here that later on, I think maybe for the 10 years 15 years, people are having the only coaxial, what they call, all the three directions are in one transducers, or accelerometer, what you call, wherever you are going to use the probe, that is known as an accelerometer. So they say that you need not to have this probe in different directions. But even then, what I would suggest you, if you really want to know about your machinery, if you really want to know the proper vibration, you must have the vibration measurement in all three directions. Why? Because not only it will give the different understanding of this equipment in different directions, what is the vibration. Based upon that, you can know the region of the vibration, you can know the why the vibration is originating and where it is originating, how it is affecting the whole equipment. So there are many importance. Based upon the direction of the measurements, you can know direction of the measurements, you can know the source of the vibration. So you must measure all the vibration in all the three directions and each bearing housing: horizontal, vertical and axial. Now second thing, now apart from the vibration, what you can measure, you can measure the speed from these measuring equipments, and you can measure the phase. This phase measuring and uh, phase measuring and the speed measurement, these are needed when you want to confirm something. I will take you very interesting example, that when you are taking overall vibration and the frequency spectrum, and when you see the frequency spectrum for a particular bearing housing and for a particular direction, that it is giving the highest vibration at the 1x, and in all the direction, horizontal and axial, you are having the, you can say, same amplitude or slightly 30-40% different. Now the question arises, how would you identify whether it is an unbalance or it is a misalignment? Sometimes what happens, that if in all the directions the measurements are equal, people generally guess it is a balancing problem. There is a unbalance in the rotor, or you can say the impeller, or somewhere rotating part, rotating component, there is an unbalance. Now it is not necessary that when you are having 1x it is an unbalance. Now the question arises, how would you confirm? So for the confirmation purpose, we are using the phase. You need not to, you can say, generally use phase and speed for each and every equipment, but when it is important and you want to identify whether this 1x is coming because of the misalignment or the unbalance, you have to confirm. For the confirmation purpose, you need a phase measurement. Phase measurement will clearly tell you whether it is unbalanced or misalignment. Apart from that, phase is also helping how one bearing is helping, is behaving in comparison to another. What you call the, you can know the mode. So by knowing the mode, you can also know the severity of the misalignment, or which driver are driven, which bearing you are having more problems. So phase is also help in that. But what I would tell you that generally avoid measuring the phase only for the confirmation purpose. You need to measure phase because it is extra activity and you don't want to that extra activity to be done. Now another thing is that apart from the measurement of the phase, apart from the measurement the speed and the vibrations, you have a two mode for the measurement. Sometimes you want to see only the time domain. So for the time domain, the measurement technique, or you can say configurations, how many lines you should have, how many, you can say, time you want to measure. So if you are if you are interested in knowing the time domain of the vibration, you have to take that. But in my experience, there are very few experts who can really identify the problems from the time domain. So generally in the industry, the practice is that you are measuring this vibration for the purpose of analysis in the vibration spectrum. Now vibration spectrum, for that you have to have another software. So portable machine, portable measurement machine, and downloading all the, you can say, signatures in the softwares, and then analyzing. And apart from that, you should can have the history, or you can have other information in this software also, or you can have the configuration of the equipment, you can have a schedule when to measure. Now another important point is that how you are measuring the vibrations. When you are normal schedule and everything, what is the function, periodicity? I mean, this equipment should be measured every 15 days or every month or every 2 months. How would you decide? So the practice is that depending upon the criticality assessment of the equipment, generally you categorize in the ABC, or vital, essential, or critical. Depending upon that, you should have the periodicity. In my experience, I generally have a 15 days for the critical and 1 month for the semi-critical, and others, non-critical equipment, we will have a 2 months or 3 months, depending upon your manpower, depending upon your availability of the people, and the people who are going to take the vibration, and people who are going to measure the vibration and analyze the vibration. Depending upon this manpower, you can decide. But most important thing that whenever you see the vibration severity that is beyond what is normal, then you have to think in a different way. You cannot say vibration is high and stop the machine, or you would say simply that by taking only one vibration reading, you can say that no, now we need to stop the machines, because the stopping of the machine is the last resort. People don't want that you should recommend, you suggest them stopping the machine. Before that, they want to know what is the region, what is the severity, how much it will impact, what are the consequences if the vibration remains high, whether it will damage bearing, whether it will damage impeller, whether it damage any other components, how you are going to rate, and whether it is any hazard, any safety point of view, or machine point of view, any harms are there. These things should be answered by the engineers, maintenance engineers and vibration engineers both. So it is a very important. Depending upon the readings, how would you conclude? So what I suggest in my experience, that never see one reading, never see two readings. You have to monitor it. Now for the monitoring purpose, you can say periodicity or period, when you should have another vibration measurement. That depends upon what is the severity of the vibration, what is the severity of the equipment, where it is located, how much critical it is for the plant. So monitoring, if you are taking 15 days, you can keep it 7 days. Initially you can have a daily vibration. If you know that vibration is very high, it can break any time, but you want the time to locate the spares, to locate the components, to make the plan. You want some time. So for that purpose, you should have the monitoring period when the failure actually will happen. What you call it is a potential failure and failure, actual failure. So now your responsibility is that you should have a minimum damage for the potential failure to happen in the real failure. Therefore, vibration technology is very very important and very very supportive and helpful. I talked about the casing vibrations. Now I will talk about the shaft vibration. Shaft vibration is a online vibrations. You have a proximity proofs in the 90% of machines. Apart from the vibration, you are measuring the temperature also, and you are directly taking vibration. But these vibrations also giving you the peak to peak displacement. They are not giving any other information. Although there are softwares, particularly from the Bentley Nevada, in the name of the system one, then they will say it is showing the orbits like that, shaft central line or rubbing spectrum will be like that. So there are many things you can depend upon, but actually they are doing nothing, simply measurement of the displacement, measurement of the shaft vibrations. So depending upon their signature, their severity, then you can monitor not only online but you can also monitor through the casing vibration. So now you have a two technology for one machines. Casing vibrations you are measuring, and you are also measuring online vibration, and you have the also facility to take the gap voltage to verify whether whatever you are measuring is really your pros are working or not. That you can verify by measuring the gap. So in such a manner you would like to know the what is the severity and what is the problem. Now if the vibrations are coming as per standards, they are beyond, or as per the OEM recommendations, are at a higher stage, or if they are giving the alarm, the monitoring period you can have what when you should monitor. I mean how many times you take the vibration now. So depending upon the severity, depending upon the you can say criticality of the equipment, and depending upon your analysis, you decide when you should stop the machine so that no catastrophic failure happen. So sharp vibration is also very important. Generally it is employed in the online critical machines, and they are already coming with the proofs and all that. For that, vibration software may be the Bentley Nevada system one. In the system one, they have also helped in the analysis by writing many algorithms, writing many you can say rules and regulations. You can understand, but as a person vibration analyst, as a person maintenance engineer, I would like to tell you that don't sit only in the front of your vibration software, or you should not restrict only for the vibration measurement. You have to go into the field, analyze the things, vibration and everything with respect to that specific equipment, what type of equipment is there. It is a geared compressors or large compressor, multi-stage compressor, only single stage compressor, overhang pump is there or multi-stage pump there, whether it is a boiler feed water pump, or it is a hydrocarbon. You got all these factors. When you have a more and more information, you will have a more and more idea about the equipment, then your analysis, then your prediction, of the problem, then your you can say capacity to tell when and how and what severity is there, and when the machine will fail, and what action and steps you should take, and when you should recommend the stopping of the machine. That depends totally on you, and that cannot be done only when you are analyzing. Maybe you are a certified vibration analyst category 2, or there are many categories, category 3, or you are known it is a wonderful expert of the vibration analysis. But I would recommend and I would request you, don't restrict yourself only for the vibration analysis, because I have seen in my experience that the people know about the vibrations, are the people you can say coming from the outsourcing. They are measuring the vibration, but they cannot analyze and predict in a proper way, because many physical things which they cannot see. You might heard about that many people giving the remote services, I mean remote monitoring. All these tools are going to help and support, But if you really want to know the outcome, you must know how to measure, for where to measure, how to analyze, and what is the predictions, and how to confirm the problem, and what is the, you can say, monitoring period you should have, when you tell the corrective stations, corrective actions should be taken, and when you should plan for the spares and all that. These all responsibilities you can only respond, you can have a greater credibility in your site, in your plant, as a vibration engineer, as an analyst. Only then you are predicting most of the problems in the favor of the productions. So there is a trade-off between, you can say, stopping of the machine or non-stopping the machine, and your credibility will very much depend upon how accurate you predict in the time of the crisis. So taking the vibration measurement analysis is another part, and predicting the right cause and what action should be recommended, so that there is a less and less harm to the plant production, or you can say downtime of the equipment or the maintenance equipment. Only then you will have the credibility. Another thing I would like to tell you that vibration analysis, or for vibration analysis, it takes time, maybe taking 1 year, 2 years, 3 years. Only then you can call your experts, and you need to have a lot of vibrations, lot of spectrum analysis, lot of readings, lot of learnings you have to do. But the best thing is that you should always close to the machine. Thank you very much. I don't know whether you liked it or not. I have not told you the many technical things you can learn from many other literature available, but what I would suggest that it is a very important, and you should see whether you are really skilled to predict any problem of the machines through the vibration technology. Thank you very much. Please give me your suggestions and how this video could be improved, and what topics you would like to talk about, because it will be my pleasure to share my experience, my, you can say, knowledge about the topics, and I would like to have a response from you. Thank you very much. Thanks.